Welcome back to Ox Tools. I'm Tom. So what we got today is a nice batch of Meatloaf. And for those that are new to my channel, what Meatloaf is kind of a mixed bag of unrelated subjects. Typically, it will be about the history, the science, or the art of this wonderful trade that I'm involved with, machine work and engineering. So sometimes there's machining content in the Meatloaf and sometimes there's not. So we got a pile of stuff to take a look at, some really interesting things, and pretty much always interesting. So let's check it out. All right, this first one's pretty cool. So this is a meter out of a power generation plant that measures the current or the energy coming out of a power plant, and this one goes up to 100 megawatts. Now that's a lot of power. Okay. Now clearly with these leads here, they're not shunting this into 100 megawatts, and I'm told by electronicers that I showed this on Instagram actually, and some electronicers kind of told me how it works, and then somebody actually sent me the manual for this particular meter. So they have current transformers which go around some of the feeds or the outputs from the power plant, and they induce a voltage and a current, both, that they feed into this meter, and this meter does some math internally to determine what the output is there. Now, you know, this is a little simple, well, not so simple, a cool little meter, right? And to give you an idea of what a megawatt is, right? So a lot of these things, you know, we talk about them, and they're so far off scale that there's no particular relation to anything that we can kind of get our brain around, right? You know, in particular in astronomy, that's always a tough one, right? Now this one's a little closer to home. So most of you guys you have automobiles or cars, or maybe you have race cars or race motorcycles and things like that, right? So you can think about horsepower. And that's another way to think about watts. And in Europe, the watt is a standard unit, so, you know, they measure every motor outputs, instead of a 1 horsepower motor, they measure it in kilowatts, right? Thousands of watts. Well, this is millions of watts here. And so to put it in perspective and kind of relate it back to something that people can understand, right, is horsepower, right? And so your car might have 200 horsepower, or if you have a kind of a performance car, maybe it has 3 or 4, or maybe even 500 or 600 horsepower, right? And then you got your, you know, top fuel dragsters at 10,000 horsepower, things like that. Well, 1 megawatt is about 1,340 horsepower. Okay, so this is like 134,000 horsepower for whatever generator this was connected to. So and that's continuous, 24/7, right? The thing's just running. Now, you know, this meter is probably not pegged, you know, when it's in operation, right? So you know, most meters, when you set them up, you want to be operating the meter kind of in mid-scale typically. So this thing was probably normally reading somewhere around 50 megawatts, right? So but it goes up to 134,000 horsepower, which is kind of impressive, right? And like I said, it's not coming through those leads, but anyway, this comes to us from Dan Kraft, who's out in Kansas. And he does power station stuff, and he sent me a couple of things, and the meter was one of them. And I might try to hook this up to some variable load around the shop somehow, although I'm not any expert at electronic stuff. So it'll be kind of fun to hook this up to the CNC, and when I'm taking a cut, it gives me some reading or whatever that correlates to how much power I'm using. So anyway, Dan, thank you very much for sending this along, And I'm going to show one more thing from Dan, and then we'll move on to the next thing. So this is just a kind of a random book that that Dan included in the package that he sent me. But it turns out that's actually pretty interesting to me because I'm working on something that there was some good information in here on here. And this book was put out by Barber Coleman. And Barber Coleman's an old-time U.S. company. They made lathes and gear hobbers and many different kinds of manufacturing equipment, and it was a first-class engineering company. Now this has data on gear hobbing and cutters and tapers and all kinds of stuff. But the thing that I found interesting in here is it had a bunch of information on splines. Now I'm working on something that's dealing with some splines right now. And I will tell you that honestly, there is precious little information. In particular, Machinery's Handbook, they've removed, in the newer editions, they've removed some of the parallel tooth splines as opposed to an involute, which is a curved tooth. These are parallel or SAE splines here. And this has quite a bit of information on it for permanent fits, sliding under load, different numbers of teeth and etc. So it's actually kind of a nice reference, for doing some design work related to splines. So I found some stuff online, but anyway, I found it. Even with my extensive library, that I didn't have any real good references to splines. So Dan, thanks once again. This is a great little book from Barber Coleman, and oh, look at that, tapers, all kinds of neat stuff, and it's just old, right? Old and cool, right? Do I have a date in here anywhere? I don't know. I don't see a date. Maybe in the back. Let's look in the back real quick here. I don't want to take up all our time just flipping around in a book. Anyway, Barber Coleman book. Thanks again, Dan. This next one was sent to me by my friend Gordon Long, and he works in the UC Berkeley physics department, and he's a machinist and nutty tool collector like me, and we have wonderful talks, and I go visit those guys in that shop every once in a while when I feel like getting away from my shop. So anyway, Gordon, thanks for sending this along. This is some cool shop art, and it's a drawing by a guy named Edmund Lewandowski. And it's, basically just a pile of chips, right? And it's just kind of pleasing to look at. And it's got some nice colors in there, and chip colors and different materials and whatnot. So I think I'll probably mat this because it doesn't want to lay flat, and then find a place to hang it in the shop. But Gordon, thank you very much for sending this along. This is always cool to get shop art to decorate the walls, and thank you. This next one's pretty cool. This comes to us from a gentleman named Rich Sweet let's see, he's in Rio Del, California. Anyway, he sent me a little box of goodies here, and what we have here is, this is kind of interesting, and for folks that have struggled to grind threading tools, this is a special block for helping you grind threading tools. And I've heard these referred to as tumble blocks, where you have kind of a repetitive grinding operation, and that maybe has a bunch of different angles on it, and you clamp the part in a tumble block and then tumble the block around to create all the interconnected angled surfaces. And that's kind of what this one's about. Now these are little adapters for, actually we probably won't even talk about those. And I've been fiddling around with it here a little bit, and it's quite well made. It's very nice. and it was made by the Robert Clark Company. And for those people that might want to try to find one on their own. So, but let's check it out here, because this one does 60-degree threading tools and then Acme threading tools. So let's look at the 60-degree case first, right? And this particular one's on center, and this is 60 degrees. So we're just gonna stick that in there, and let's see, do I want it? Yeah, I'll stick it in there, and so we can turn it over on its back too to grind that front relief. So, all right, let's put that in there, and then these are for grinding offset tools and tools. Old-timey tools that fit in like an Armstrong tool holder that has its own angle to the tool holder. So those aren't relevant to our discussion right now, but let's take a look at this. So the idea here is, and you see it's got some facets on it here. There's a big facet there, okay, and then another facet there, all right? So in this case here, now this is for the surface grinder. So sorry, I didn't say that before. So the wheel is parallel. Let's pretend this is the magnet of the surface grinder, and then our wheel is parallel to the surface. Okay, and I'll simulate that with the rule here too. Okay, actually this is probably a better view for you guys. So this is our surface grinder wheel coming this way. So we clamp a tool bit in there, we dust this off, get it flat, and then we can put a front. What is that angle on the tool bit? That's back rake, I think. So this would be the back rake here. Okay, so then we come across again, and now we create this positive leading edge here, right? Okay, so in this case, now we can lay it over on its side here, like so. Okay, and I'll turn it sideways so you guys can get the. Actually, it's this way. This is now parallel to the direction of grind here, right? And so our surface grinder wheel would shoot, come across here and create this relief angle and one side of the of our 60 degrees here, right? Okay, and then flip, rinse, and repeat. That one, yeah, it's that one. And no, it's that one. Sorry. So this, like I said, this does Acme and 60 degrees, so I got to look at it to make sure I'm doing the right one, okay? Then zit, 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 rinse and repeat, and then we can lay it all the way over on its back, okay? And it has an angle here that we can dust a flat on there as well. So pretty cool. Now, that said, let's take that one out here and let's stick an Acme in there. That's a little bit bigger, I guess. Like so here. And normally, you know, you probably wouldn't have them hanging. Actually, we're not using that back angle, so we could probably just do it like that. All right. So now here's your Acme angle here. All right, like so. And that just sticks down to the magnet, and it. Now you see I have a slightly different clearance than what this is prescribing here, so it's looking for a little more side clearance than what than I've given this tool. So maybe I should go regrind that, right? All right, and then the opposite side this way. Is that it? Is that the right one? Well, see, now this is interfering back here. All right, come on, Mr. Wizard. Yeah, sure, we gotta stick that out a little ways, huh? Okay. All right, and then we grind this way like that, and then I suppose that you can lay it on its back and do this flat as well, if it's not sticking out. Anyway, Rich, thanks for sending that in. That's pretty cool, little block. I've never had a chance to play with one of those. I've always just kind of hand ground this stuff myself, right? You know, with and you check them with a gauge, right, and make sure that you're lined up. But if you want to do like a super califragilistic job, this is like a good tool for that. And or if you do a lot of threading tools. And so, Rich, thanks for sending that into the show. Appreciate it. And if you guys want to try to find one of those, that's a Robert Clark Company thread thread tool grinding fixture Model A. And Model A, what is that? I wonder what the, wow. So what that means is there might be a B and a C. This is a California company, Los Angeles. That's kind of cool. And he actually sent me there's a patent on this too, and there's the patent number if you care to look it up and study this. But it's it's a lot of pros on how to use this thing. So, Rich, thank you very much. This next batch. So I guess the word's out that I collect kind of machine tags and machine nameplates, and some people picked up on that, and they some guys sent me some, which are really cool actually. These are really neat. So let's start here. This first one here, this thing is like made out of cast iron, man. This thing weighs a ton, and this is from Joe Way from Sierra Specialty Auto, and he came to the first kind of NorCal metalheads event at Chuck Bommarito's place, and we had a great time. And anyway, he sent this along to me and for my collection here. So I was figuring out how to mount that sucker, man. It weighs a ton. So Joe, thanks a lot. That's pretty cool. I like that one. And I think he might have told me what a Waddell is, but I don't remember now. So I'm not gonna bozo it and try to guess and remember. Anyway, it's kind of neat. So this next one here, this is a gentleman that I have not met him face to face, although he is a friend of a friend, and he's sent me a bunch of stuff. Super nice guy, and he's in Kingsburg, California, and this is Jim Rudholm, and he was, I don't know, at the scrapyard or scrapping out a big compressor. And is it an Ingersoll Rand? Is that, did I remember? Yeah, Ingersoll Rand. And this is kind of a U.S. Government property tag here or something. So anyway, it's made out of, I don't know, 80,000 thick brass, man. You know, that's pretty cool. And it's got a little serial number on it and whatnot. Anyway, good looking tag there. That'll go in the collection really nicely. And we'll do the same thing, you know, we got enough to put them on a board and frame them or whatever, we'll frame them up. I got another batch going right now. So Jim, thanks very much for sending that from Kingsburg, and thanks. I don't know, what else do I say, man? That's pretty cool, brass tags. Now this last one here, this was pried off of a cylindrical lapping, a centerless lapping machine, okay? And this is Graham Petty, and this is a run-of-the-mill machine and fab, and he's in Portland, yeah, not Porter, Portland, Tennessee. And he said, hey, I got this tag I pulled off of this machine that I scrapped out. He bought this machine in an auction lot, and I don't know, he paid $5 for it or whatever it was, and didn't really have the room for it. Stripped it of the stuff that he wanted from it to do whatever he was going to do with it, and then pulled this tag off, and thought I would be keen on the tag, and I certainly am. I'm very keen on this tag. So Graham, thank you for sending that in. And you know, when we were talking on email, he told me what machine he had, and I said, hey, you still have that machine, right? Because cylindrical lapping is something I haven't played with yet, and I've considered actually building a cylindrical lapping machine, right? And he goes, oh no, he goes, I pulled it all apart, and he say I saved the rollers and this tag, and that's about it. And I go, okay, all right, thanks. And anyway, so you know, kind of a funny story there, but the very cool tag. I love this tag here. This one's aluminum here, and but it's got color on it, and it's got a fair amount of detail, and it has that kind of little after Art Deco kind of motif to it with the fonts and the parallel lines and things like that. So there's some kind of art history in there. So Graham, thanks very much, and Jim, thanks very much, and Joe, thanks very much for sending these machine tags in. I really appreciate it, guys. Well, I went to put those tags away, and I found one more that I forgot to mention here. This one's from Joe Miller out in Pennsylvania, and he sent this tag along. This is Jones and Lamson. These guys made what I know them for is optical comparators, and so if I had to guess on the date on this tag, it says a Textron company. And Textron bought up a lot of these kind of old-timey U.S. companies that were big in the 30s and 40s, and I want to say they bought them up somewhere in the 60s sometime, would be my guess. I don't know that for sure. Maybe somebody out there throw some up in the comments if you know when Textron really kind of rose up and started swallowing up a bunch of companies. And I think they nabbed Pratt & Whitney, small tools division, a number of companies like this that were kind of standalone companies previous to that. This is a big conglomerate here. Put it this way, this is the beginning of the end here for if your company gets bought by these guys and thrown into a conglomerate like Cooper Tools or Textron or whatever, the end is near. So anyway, Joe, thank you very much for sending that in, and I'll put that in the collection. Thank you, sir. So we were talking about the Barber Coleman Company a little while ago, and this is a little instrument that I picked up at the Summer Bash. And it's kind of an interesting piece, and you know, if you open a box like this and it has purple velvet inside, it was probably a really expensive instrument at the time. And purple is the color of royalty, I'm told. And I thought I saw a program on it years ago about how they used to make purple dye for dyeing cloth. And this is back in the medieval times, and they used to collect these little snails or these little shellfish and crush them up and ferment them, and it produced this kind of intensely purple dye. And the process was really expensive, and difficult, so that's why the purple was reserved for royalty. Now, that said, what we have here is something called an impressor. And it's basically a portable hardness tester for aluminum, and so that you can check the fabricated condition of or post-weld and pre-weld and hardness of particular alloys, or potentially identify different alloys if you have known samples, so that you can do kind of comparative analysis. So let's check it out. This thing's pretty cool. Let's get it out of its purple velvet there. It's got a little dial indicator. It's got this very stylish, like heavy-duty handle here. You know, it's almost like brass knuckles, right? So what it has, and we'll pull the little protective cap off here, is it has a little tiny indenter here, right here. See, it's right there. See, it's sharp. Can't you feel that? And so anyway, it's got a little indenter there that's tied to this this dial indicator here. So what we have is this is 6061 here, and then we have a piece of 7075 here. So actually, you know what? I think I want to do it like this so you guys can see the dial properly here. Let's see if I can push down on this and get a reasonable reading here. Okay, 68 or 65. That's probably in the same hole, so we probably should move over a little bit. See if we get the same number. Okay, 70. All right. All right, so that's our 6061, and it puts a little Dingus McGee in there. So, but it's pretty small, and it's still there. All right, let's do our 7075 here. Hopefully the, you know what, I should look in the, oh no, it's not washed out. Okay, great. This is a little bit hard to operate upside down, but I'm trying here. All right, let's do this one. Okay, 85. Let's move over a little bit. All right, 86 or whatever. All right. So it's actually a fairly stiff little spring. So anyway, it's kind of cool. It's just a little portable hardness tester. So if your operation had, let's put this back on here so I don't stab myself with it for starters or wreck the thing. So if you had an operation where you were generating scraps and you needed to check them, or you wanted to, let's say, for example, you welded these two pieces together, right? So there's this heat affected zone, right? And then as you move away from that heat affected zone, the material kind of returns to its bulk qualities. Now, you wouldn't weld 7075 to 6061, that doesn't work. In fact, you can't weld that alloy. This one you can. And I haven't fully read the instruction book. But let's see here, maybe we can, this is pretty crispy here. Oh, okay, actually pretty good. I'm glad I opened that up. Portable hardness tester for aluminum alloys, soft metals, and plastics. Maybe I should go grab some plastics. There it is, and it tells how to hold it. Not like I was holding it, of course I did it wrong, right? All right. Anyway, it's a fun little tool, and I saw it on a guy's table, and anyway, picked it up and came home with me. So Barber Coleman Impressor portable hardness tester. So here's an interesting little grab bag from a fellow down in Southern California, Mike Tarab, and he runs food equipment specialist. So he does welding and fabricating. He sent me some of his favorite abrasive combinations for blending stainless steel welds and things like that. And then he included a little grab bag full of cool stuff here. So this is the thing we'll talk about here in a sec, but let's, and some of you already know what that is, but we're going to show it because Mike had a question about how it's used. And so we got some, horizontal mill cutters here. There's lots of these around. They're very cool to look at, the different shapes and whatnot. And occasionally you run into a situation where you mount one of these on an arbor and use it in a vertical machine or whatever. But these are some cool angled ones here for dovetails and things like that. I haven't really looked at that one. That one's been reground a bunch of times here. So anyway, let's set those aside. So we got a big fat roughing end mill, and this is high speed, and it's got some kind of coating on it here. And I'll tell you, and I've talked about this before, for guys with lower horsepower machines, this is a really good option, and for metal removal, because you have all this surface area, and it really frees up the cutting, and chip management is pretty easy too, because the chips are small. So if you haven't tried roughing end mills, you probably should, because like the name says, they're pretty efficient at roughing stuff. So key seat cutter here, made in Yugoslavia, and I don't know, not much to say about that. That's a big wide one there. I've got a tap wrench here. Now this is an interesting one because it's ratcheting. Okay, so it ratchets in that direction, or if we shift this way, it'll ratchet in that direction. And then if we set it in the center, then it locks it up both ways. And sliding hand. Let's see, who makes this one? Some Miller. Oh, it's West German. Oh, this is made in West Germany. How do you like that? How do you like that? So, all right, so tap wrench, cool. And a little counter drill there, or counter bore. That one's carbide there. That one looks pretty good. I have to measure that one and see what screw size. Looks like a number 10, something like that. Engraving tool. So, we talk about D-bits and whatnot, D-bit grinders and things like that. This is the kind of cutter that you would make on a D-bit grinder, where the blank is split halfway down the center, and then you put your profile on there, and then you grind the relief behind the cutting edge there, so that's how that works. All right, and then let's see, we got this is a straight up high speed Niagara counter bore, 3 flute, nice looking one, nice and sharp. And what do we got here? Let's see what we got here. Oh, okay, so this is a little carbide boring bar here. Looks like it's been, dang, it's McGee'd there, so it needs a little bit of work, but most of the work's already done, so it's pretty easy to touch that up and bring it back to life. Same thing here. It's got a nice flat on it. This one's a little shorter here. Yeah, this one's kind of chipperinoed there, but that's okay. So we got diamond grinders for, and there's a pretty good looking end mill there. And this is a Ultra tool, 4 flute. Got a corner radius. Yeah, tiny little corner radius. Feels pretty good to me. So that's a good size 3/8. You can do a lot with a 3/8. All right. Anyway, Mike, thank you for those. Let's put those away, or put it back in the tray at least. And let's talk about this thing here. Aside. Let's talk about this little guy right here. So what we got here, this is, my dad had these things, and he always called them Yankee screwdrivers or Yankee bits or something like that. And what this is it's got a push action with a spiral, so you can drive screws with it, or in the case of this one here, let's get one of the Bitmeisters out of here. Let's get a big one out here. Let's get the number 8 out. How about that? Huh? All right, come on, Mr. Wizard. Where is it? All right, you know what? We're just going to take the whole... Oop. There's the guts of the thing. And there's all the bits. Oh, look at that. The little spring plunger's made out of wood. How do you like that? Well, there's some of the bits. All right, let's put this back together. What was I doing wrong? Oh, now you've done it. Now you've done it. Nothing simple, right? All right. Put that in there. Put that in there. I think we don't want that compressed. Need 3 hands here. I figured out how it works at least. Okay, that's a good one there. Let's try that one. All right, so in it goes. We tighten it up. Now this is actually a drill bit. Okay, it's not a screwdriver, it's a drill bit. And we're going to demo it on a piece of wood here. Stand by. Okay, so I'm ready to go here. Got a piece of wood, and we're just going to jab a hole through there. I think these are sized for screws too, wood screws. Oops. Oh no, look at this, the whole thing fell apart. Blew the wood out. The handle came apart. That's the real winner here. Alright,